Anyway, so today we will deal with the optimization. Okay, class. I will just introduce to you the linear programming. No, I will just introduce to you the linear programming because you will have a separate subject of linear programming. I guess in your advanced engineering mathematics, basahin madiskussan ninyo ng linear programming otro. So maybe I will just deal with the basic concepts, no, and the simplest way of solving a linear programming model and linear programming problems, no. Okay. By the way, what is this linear programming models, no? Okay. So when this is used, no, linear programming models are used for optimization problems. What is this optimization? When you say optimization, you try to identify the best solution as possible. No? The best solution as possible. So usually they are used for planning. No, they are used for planning. Planning, no, especially kung magamit na mo og networks, no. So magamit kayo ning kuan kaning linear programming, no, linear programming models. Okay, dili ni planning kung ano kanang magbuhat mo blueprint, no. It's related to business planning, no, business planning ni siya. Okay, so usually in business planning, uh, we will try to either maximize the profit, no, maximize the profit or minimize the cost. So that is the uh, common problems where we apply kaning linear programming models, no, linear programming models. Okay, so by the end of this lesson, so what you need to learn is that number one, we'll try to translate descriptive statements into mathematical models. So I would like you to review on our lesson related to um, uh, atong from transforming expression into mathematical symbols or mathematical statements. Okay, so I wanted to review our lesson in chapter 2 because we are going to apply them here. Then formulate linear model for a given linear optimization problem. And number 3 is to determine the optimal solution of a linear programming model using graphical method. Okay, we will just focus on the graphical method. No, we will just skip the Excel application. So focus lang ta on the graphical method. Before we proceed, so I want you to review on the following. Finding the solution set of the systems of linear equations. Um, we need this one, especially when we try to graph unya daily whole number ang iyang intersection point. No? So to be exact, so we need to review on this lesson. Okay. Then also, I want you to review on sketching the graph of linear inequalities. Anyway, we will just be introducing to you. I will not be strict with this one. I will allow you to use a graphing calculator for sketching the graph. No, but if you are confident with manual computation, so you can do manual computations. No, for this lesson, I will make use of Desmos. No, Desmos as our graphing calculator. Uh, so that we can fasten up a little bit our lesson, no, related to this topic. And number 3, so I wanted to remember also the finding the solution set of the linear inequalities. So I want you to review on these 3 lessons, no, before studying linear programming. Okay, now let's start. No, we will start with this problem. Let's say we have the ABC Furniture Company. Ames has producing two kinds of products, tables and chairs, which is to be processed through assembly and finishing departments. Um, in the assembly department, okay, the maximum time available is 60 hours, while in the finishing department, it's 48 hours. No, manufacturing one table requires 4 hours in the assembly line and 2 hours in the finishing line, while the chair takes 2 hours in assembly line and 4 hours in the finishing line. Okay. When it comes to profit, okay, one table contributes to 80 pesos of profit, while the chair contributes to 60 pesos of profit. So the problem now is we need to determine the number of tables and chairs to make per production period in order to maximize the profit. No, so those that will be our problem. So we need to produce uh, certain number of tables and chairs that would maximize our profit. Okay, so that will be our main problem for uh, this one. Okay, so that will be our main goal for this problem. Okay, so the first step here is we need to define our variables. No, so that is the first step in the linear programming, solving a linear optimization problem. No, so that is the first step. So we define the variables. In this case, since the quantities involved are the tables and chairs and the profit, so we let X be the number of tables and Y be the number of chairs. And we let Z be the profit. Okay, so those would be the variables in this problem. The next one is we determine our goals. And in this problem, okay, no? So we need to maximize the profit. Particularly, the goal of the problem is to determine the number of tables and chairs to make per production period in order to maximize the profit. Ayan, so that is our main goal, no? So since we have now our main goal, okay, we can now define our objective function. Okay? So we can now define our objective function. So, okay, it says here in our objective is to maximize the profit, no? And one table contributes 80 pesos of profit and one chair contributes 60 pesos of profit. No, so we can define now our objective function as this one, z times equals 80 times the number of tables plus 60 times the number of chairs. Yun. So that is our objective function. Okay, since we now determine our goal and define our objective function, next one is we determine the conditions we need to satisfy in the problem, and we call that as the constraints. No, as the constraints. Okay, the first condition that we have is the maximum time for availability for assembly department is 60 hours, while for the finishing department is only 48 hours. So those are the conditions. Another condition is that for manufacturing one table, it takes 4 hours in the assembly line and 2 hours in the finishing line. And one chair takes 2 hours in the assembly line and 4 hours in the finishing line. So those are the conditions. In summary, we can have this table. No, we can have this table. Okay, so we need to translate this into equations or inequalities. No, so we need to translate this one into equation or inequality. So for the first constraint, we have the assembly department is available for 60 hours in every per production period. Thus, we can write 4 hours times the number of tables plus 2 times the number of chairs is lesser than or equal to 60. No? While for the finishing department, so 2x, which is the number of tables, plus 4y, which is the number of chairs, is lesser than or equal to 48. Yon. So so we have now defined our two constraints, no? Then we add our non-zero constraints. Okay, we for every linear programming model na gini siya always si non-zero constraints, no? Kay we need to be sure that our answer, our optimal solution is positive, no? Our optimal solution is positive. In summary, this is now our linear programming model with the objective function of we are going to maximize z, which is equal to 80x plus 60y, subject to the following constraints. No? So constraints for the assembly department, constraints for the finishing department, and the non-zero constraints. No? So yon. So that is how we translate the whole selection into a linear programming model. Okay. So yon. So, now how are we going to solve this one? So that is now the problem. So we need to determine the optimal solution. No. So we need to determine the optimal solution for the linear programming model. So for this case, okay, we are going to use the graphical method. Now, we are going to use the graphical method. Okay, I want you to take notes on screenshot na sa inyo muna ang given. Then I will transfer you to another window. Sige, ako sana i-stop, no? Wait lang. It should be top here. Okay, so the first constraint that we have, so I will just be, we will just make use of Desmos, no, para dali ra siya sana dali ra i-graph ang atong mga constraints. Okay, so the first constraint is, sorry, duha day sila. Okay, so the first constraint is 4x plus 2y. No, sorry, plus na ito. Lesser than or equal to 60. So, mo ni siya ang graph, no? So, that is the graph. Okay. The next one, we have 2x plus 4y lesser than or equal to 48. Okay. So, yun. So, then we also have the non-zero constraints. X is greater than 0 and y is greater than 0. Yun. Okay, so this is the graph for the 4x plus 2y lesser than or equal to 0. And this is for the 2x plus 4y lesser than or equal to 48. Then that is greater, x is greater than 0 and y is greater than 0. Now, so yun, so now we are going to determine the solution of the solution of the linear inequalities. We know that the solution of the linear inequalities is the region kung saan uh, nakas naka-shade, no, common shaded region, no, for all inequalities. And for all the common shaded region, we have this part, kanino? Kaning quadrilateral. Okay. I don't know how to mark this one, no, because but anyway, I will just state the intersection points. Okay. The region, okay, the region bounded by these corner points, no, kana nga mga region, kani siya. This is the solution set of our linear inequality, no, kani siya. So, mo ni siyang solution set. And this solution set class, we call that as the feasible region. Okay, unsa day ng feasible region? The possible solution for the linear programming model. So kung possible siya, meaning kung any points here, mo satisfy siya sa atong constraints. Ano? Okay. So when you say feasible region, it is the solution, no? It is the solution that would satisfy all our constraints. And nabilong na siya dire. No. Okay. The solution that would satisfy our constraints, we call that as the feasible solution. No? And the set of all feasible solution, no, we call that as our feasible region. No? So, kani siya dire, kani siya, diha, kani nga na-enclose nga quadrilateral, kani na-enclose sa quadrilateral, that is our feasible region. No? But in our problem, we determine the optimal solution. No, optimal solution. So, ang optimal solution is the best solution. And based on the goal, we need to identify, now we need to identify the solution that would contribute to the maximum profit. O naara na siya diri sa atong feasible region. No? Naara na siya diri sa atong feasible region. Now, the maximum or minimum or the optimal solution, no, lies in the corner points. Now, lies in the corner points. And these are the corner points, no? 0, 0, 0, 12, 12, 6, and 15, 0. So, naaning upat ang atong optimal solution. So, by trial and error, aning through aning upat, no? Kaning upat ka corner points. So, just simply substitute it to the values of x and y and determine which values would contribute to the maximum profit. Now, all you have to do is to substitute each of these corner points and determine which of these four would contribute to the maximum profit. No. So, okay. Let me go back to my presentation. So this was our graph earlier, no? This was our graph. Okay. So ang corner points is kani, diha, kani siya, o kanino, 15, 0. So based on the graph we have earlier, our corner points 0, 0, 0, 12, 15, 0, and 12, 6. And based on these four, ang nag-contribute to the optimum solution, which gives the maximum profit, is 12, 6. No? And 12, 6 contributes to the maximum profit of 1,320. Yun. I forgot to write the conclusion. No? There should be a conclusion here. So our conclusion is that in per production period, no, per production period, ABC Furniture must produce 12 tables and 6 chairs to have a maximum profit of 1,320. No. So, yun. So that's how we solve a linear optimization problem. Okay, before I am going to proceed with my next slide, any questions from the group? Do you have any questions?
None, sir.
Okay, there's none. Medyo klaro naman, no? Anyway, in summary, these are the steps, no? So in summary, these are the steps. So number one, we formulate the LP model representing the problem. That is, number one, we define the decision variables. And number two, construct the objective function. Then translate the constraint into linear inequalities. So that would be the first step. Then second step is sketch the graph of the constraints. No, sketch the graph of the constraints. Then number two, locate the feasible region. Number three, calculate the value of z's on every corresponding corner points of the feasible region. Then the value that gives the maximum or minimum value for z is what we call the optimal solution. Ayan. So that is the summary of how we solve a linear programming model. Okay, so I have here another example of an optimization problem. In this one, here is all about minimization, no minimization. So I will just let you read this one and study, you know, and as a summary, this is our linear programming model that would correspond to this problem. And by the way, constraint number two and constraint number three, this one, no? Uh, Let me have a marker. So this one, Tanisha, o gani, that is derived through um, that is derived through this one, no? So 0.09 x sub 1 plus 0.060 x sub 2 greater than or equal to 0.3 times the sum of corn, what was the mixture? Corn and soybean meal, ano? Yon. Because it says here the dietary requirement for the special feed are at least 30% protein and at most 5% fiber. Yon. So ito yung this one is the at least 30% uh at least 30% um protein and at most 5% fiber. Ito 'yon. This statement, no. This is a statement. Okay. And the corresponding graph is this one. No, this is the one. By the way, this one, no, this is an example of unbounded feasible region. Unbounded siya because, no, ang iyang graph toward upward is without n. Kani siya nga part is without n. Katong kanina, that is bounded, no, because it is bounded by line segments, no. All region are bounded by the line segments. Pero kani siya, there is part that is open. So mo ning unbounded iyang tawag ani. No, unbounded ni siya. And I guess that's it, no.